Welcome to Planet Geo, the podcast where we talk about our amazing planet, how it works, and why it matters to you.
Okay. All right.
Hi, Chris.
Hey, Dr. Reimink, how are we today?
Mr.
How we doing?
Radio voice Bolhuis. What's going on, dude?
Do I, though? I try to get like right there with the microphone.
Yeah, that's right. That's the angle right there.
Like this. Is that
That's the angle. That's the angle that the microphone and the crowd loves.
It likes that one. That's right. That's right. Yeah. So how we doing?
We're doing well, Chris. We're doing well.
Yeah.
I must say, I let out with I don't really like caves, and that's true. Something about being underground doesn't suit me, but there's some spectacular stuff in caves. Verging on mineral quality, like, you and I love the cool metamorphic rocks, the cool igneous rocks, the minerals that form in pegmatites. That's cool. However, cave formations are really spectacular, and they're very delicate, which I don't know. I'm not a delicate rock kind of I don't have many minerals that would be damaged if you dropped it.
We're not soft rock geologists, are we?
Yeah, no, I mean, a lot of my mineral collection and rock collection, which is very cool, I would argue, most of them can handle being dropped off the bookshelf. You know what I mean? And I think you're the same way.
The floor can't handle it, but the rock can. That's right.
Exactly right.
They do damage when they fall. So Jesse, you asked me a question about, do a lot of students and classes go there? So I asked my students today.
About Mammoth. Okay. Yeah.
I did. And how many of you have been to Mammoth? And I was shocked. I'm going to say, I should have actually done a number on this, but close to half have been to Mammoth Cave.
Wow.
Yeah. So when I asked how many of you have been to the Grand Canyon, keep your hands up. How many of you have been to Yellowstone? Keep your hands up. How many have been to the Tetons and so on, Zion? And it's maybe 10 to 15% of my students have been to all of those combined. So far more have been to Mammoth Cave than, at least from my geography in Southwest Michigan.
Wow.
That's
interesting.
There.
I mean, that's cool to hear. That's a shocking number, actually. I'm really surprised by that, but that's great. It's just such a cool place. You could see, but like we talked about the intro chapter. So let's back up. This is chapter 3 or part 3 of our Mammoth Cave series. We talked initially about sort of general high-level stuff about Mammoth Cave and solution caves in general. The second part, we talked about the detailed regional geology that led to Mammoth Cave being so spectacular, the rocks involved, the fluid history, the different layers and levels within the Mammoth Cave system. Now we're going to talk about the features, the types of passageways, and all the cool stalactites, stalagmites, all the decorations inside the cave, which are really cool. And so if you're listening to this in the podcast, we're going to do our best. Geology is a visual science. We're going to do our best to convey this without images. But if you want the images, and this is a particularly image-heavy discussion we're trying to have here, if you want the images, head over to the Camp Geo app, first link in your show notes, click that, and download that, and you can go to Mammoth Cave audiobook that we have there.
And these images are not images that we've created with our graphic designers. These are mostly pictures of the features that we're describing.
That's right.
So they're just very helpful from that standpoint. But I also want to say that this episode is very weed friendly. We're not getting there. This is what might you see inside of the cave now. And what does it mean at a very rudimentary level? I think this is very basic, but I think it's really helpful. Seriously, Jesse, this is so helpful for when you're inside the cave and making sense of it.
Oh, absolutely. So, Chris, we're going to start here with the types of passageways. We're going to start big and then get small. I think we're going to start at passageways, then move to larger decorations, then smaller decorations. We're going to kind of work on that scale throughout this episode, right?
So let's start with the passageways. I mean, first of all, water, as it's making its own openings, as it's dissolving and finding its own pathways, this path is certainly, it cannot be described as being straightforward by any stretch of the imagination.
No.
So,
definitely not.
So we do have, with that in mind, we have some openings and passageways that you probably will encounter depending upon the tour that you're taking.
And this is one really interesting thing that I think is maybe unexpected about Mammoth Cave is I don't think you're going to Mammoth Cave and you're thinking, oh yeah, there's going to be different classes of passageways. That's not something that I think you would necessarily expect there to be. So this is kind of a cool thing that there's types of passageways, there's a big enough variety and they fall into categories so that we can categorize them. That's cool.
Exactly. But I can relate to this on such a personal level because I've been in so many caves, and it's as I'm going from one room to another, from one Mammoth Cave opening to another, in any cave I'm in, I'm wondering about the passageway that led me to this room. How did that form? I'm always thinking about that. I'm always wondering. I'm looking at the ceiling. I'm looking at the sides of the walls to see if I can see potholes and these kinds of things that show scouring actions that we see along rivers that are down cutting. So you're right. But it is something, at least for me, maybe I'm odd, and I certainly know I am. But this is what I think about.
Yeah, I mean, how much time do we have to spend on Chris's oddness in this episode?
That's true.
Why do we have different types of passageways? Really, the summary is it's the way in which water cuts through. And remember, we're dealing with flowing water. And so this is going to relate pretty closely to stream canyon formation, stream cutting kind of mechanisms. We're going to be able to use that as a visual. How does a stream cut? How does this cave passageway get cut? Because it's underground streams here. So
underground erosion.
Perfect. I love it. I love it. How?
Where do you want to start?
Okay. You go. Right. You lead us out.
All right, I will. Well, I'm going to start. And I think the way that I want to talk about these, and the way that, I should say the way we are going to talk about these is, I think the order makes sense to me in this, and let's see if at the end, it does make sense. But I want to start with canyon passageways. They're called canyon passageways. These are named by the National Park Service. And so some of these names really, to be honest with you, Jesse, some of them make a lot of sense and some of them just don't.
Like geology, Chris, like geology writ large.
It's true. These, to me, think of slot canyons in Utah.
Oh, yeah.
Think of Zion National Park, if you will. These canyoneering things where you can just rappel down from one canyon to another slot, and so on. That's what these look like. The only difference is that these slots, these are really, really tall and narrow canyons. They have a roof, though. Okay, you can't look up and see the sky. They have a roof to them. So basically, Jesse, with these canyons, we're talking about just these, you described it earlier, these are underwater rivers that just simply follow the bedding planes, and they're just down cutting as they are striving to reach the water table. That's the base level for these underground rivers.
And Chris, canyons that are on the surface, slot canyons, you talked about slot canyons, those often happen. It's just as you would imagine, it's a canyon. Think of the photos of Zion National Park, where people go hiking up into the slot canyons, right? And you're in this, lots of pictures being taken there and stuff. Slot canyons, when we think about that in the Western United States, the river is cutting down to its what's called base level. Usually we think of slot canyons forming because the ground has lifted up and the river then cuts down, is very actively cutting straight down. It's not cutting side to side, it's cutting down. In this case, it's different. The groundwater table has dropped. It's like if we took sea level, or let's go to Michigan, Chris, Lake Michigan. You live in Lake Michigan. The Grand River flows into Lake Michigan. The Grand River is pretty dang close to Lake Michigan level for most of its life. But if you took Lake Michigan and just drained all the water, and so the Grand River was now 300 feet above where it wants to be, it would just cut down rapidly, straight down through those sediments, through the rocks. It'd form a slot canyon. And so that's what's going on here is the groundwater level has dropped and these rivers have cut straight down.
Jesse, I got to say this. Thank you for bringing that in. And I'm 100% serious. I did not expect you to say it. What a great thing to bring into this discussion. The difference between what happens on the surface as opposed to what happens beneath the surface. It's down cutting by different things. It's so dumb of me to say this, but I'm proud of you for this. I can't help it. And it's so dumb because your knowledge is so far beyond, what I have. But I'm your
Chris,
mentor.
I think it's fair for a mentor to be proud of a young Padawan.
You're my young sage there. That was really, really cool thing. That thought, I'm a little pissed at myself actually, because that thought did not occur to me to bring that into the discussion, and it should have.
I think it just looks exactly like you said it before. It looks like all the slot canyons that are out in the Western United States and all over the place. And it's the same mechanical process, river cutting down. That's what's sort of going on here. So we should not spend too much time because these are just, I mean, unless you want to keep complimenting me, you can keep complimenting me for as long as you want. But
well, let's see. You gotta earn that every single time.
Okay,
you know that
right.
about me too.
All right, fair enough.
But Jesse, let's go on to the second kind of passageway, which is called a tube passageway. And I think the order in which I'm putting these makes sense again, and hopefully by the third one it'll make sense. But these look like a sewer pipe. I mean, these are tube, semicircular shaped things. And you know what, Jesse, you and I have both been in these, and I think maybe many of our listeners have, in lava tubes.
Oh,
and
yes.
They resemble the look of a lava tube.
It's
and
cool.
If you didn't recognize the rocks around and you're like, wow, this is limestone instead of like basalt, then you would swear that you're in a lava tube. I mean, they look like this a lot. So, Jesse, how do these passageways form?
You have to, again, think of like a river, or in this case, a pipe. You use the thing sewer pipe, right? You make these semicircular or round tubes. It's basically very full. Again, let's compare it to the surface. What happens to a river when it gets really full? It flows over its banks in floods. You can't do that underground. Not nearly as easily in most instances. And the same thing with lava. It kind of fills up this tube, and then it starts flowing in like a sewer pipe or like a water tube, right? A plumbing pipe. It just flows through a round tube and it gets filled up, and it can kind of erode. It can do some depositing, but it'll erode kind of a circular shape. Eskers will kind of do the same thing. When water is flowing through ice, you'll get kind of the same thing. You'll get water flowing out of a glacial front. It'll be off in this kind of oval shaped tube.
They're very cool. Sometimes you got to duck. You got to be careful in these. Okay.
Yeah.
So the third one is, Jesse, I'm sorry, I just don't like the name. I think it's confusing. This one is called a large canyon composite passage. So I don't like that.
It's too complicated. This is like a lump all term a little bit.
This is a weird name. Basically, when you have several other kinds of passages, think about, we've covered two already, tubes and canyons. If they merge together, then they form a large canyon composite passage. I think about it kind of like a roundabout, where you're driving down a road and you got all these other cars coming at you from different angles. It's not a great analogy, but it is kind of what a large canyon composite passageway is. Just the merging of several other passageways, particularly like these tube passages can collapse on each other if they're vertically stacked.
That's a good one, Chris.
So you do have the roundabout analogy, but you also have roundabouts above it that can kind of collapse down into it, So I don't know.
And Chris, what I think of here? Large canyon composite. Okay. It's a big one. It's composite. It has some canyon aspects to it. Like, okay, great. It's a word salad of the thing. There's a lot of different things. It's a multiple types of formation grouped together. The word salad makes sense here for the name in some way, shape, or form. And we deliberately don't have a photo of this one. If you see like rubble on the ground, this collapse, I think that was a really important point you made, Chris. Collapse is often a part of this process. So if you see lots of big boulders on the ground, you might have a good chance of being in a large canyon composite passage.
It was just kind of confusing to capture this in an image. It's a little bit bigger than what you're able to do, so we deliberately kind of excluded that. So
okay, so Chris, the next one, very cool one. Again, we're still in the types of passageways here. This is a vertical shaft, and a vertical shaft is exactly what we're talking about. It's an elevator shaft. That's basically it, right?
That's right. How do you think? Just posing this out, I can't help myself. It's the teacher in me coming out. So
I can
to
tell.
the listeners, how do you think a vertical shaft in an underground cavern system would form, right? I mean, if you just think about this, and the rocks, these limestone formations, they have cracks in them. They have fissures and cracks and so on. And so if you have these essentially rivers flowing along bedding planes, flowing along horizontal cracks, and they encounter a vertical crack, what happens?
It just goes downhill, man. It goes downhill
It's gravity.
quick. It's gravity. It goes downhill.
Newtonian gravity at its best.
Yeah. And Chris, we'll think of a waterfall. That's the surface analogy here, is a waterfall. It's flowing straight down. It's an enclosed waterfall. And these can be huge, up to 200 feet of vertical drop. So really, really big vertical shafts. Just a cool visual, I think, to imagine that thing with water flowing down it. That's just a cool visual.
That's a pretty impressive waterfall.
It's
if you ask
just
me. I don't care who you are, Jesse. That's impressive geology.
It doesn't matter how big your britches are. This is cool. Chris, the last category here
is my favorite one.
Oh, I was just going to say that. This is my favorite too. You beat me to it. Dang it.
Why is it your favorite? Because why is your favorite? I'm really curious about this answer.
It's the coolest mechanism for formation, I think. What about you?
Okay. Same. That's the thing. Okay. That's what it always is with me. It's the story behind it. Yeah. They look cool, but it's the story. Like this has, to me, you look at it, you're like, oh man, that makes sense. I like it.
Here's the visual, Chris. Keyhole passageway. It's like the old school keyhole, like the big brass key door. You could also just take a cheap, I don't know, like gym locker key and hold it upside down. Hold the key upside down. It looks like that. Big round thing up top, little stem going down. That's the visual we're talking about here. And so link together what we've previously talked about, the passageways we've previously talked about, and think about how this would form. Well, if you have a tube forming, a tube is near the groundwater level.
A tube passage, yep.
A tube passage is forming. What happens if you drop the water level all of a sudden? And you have this tube passage full of water. You drop the groundwater table, which we talked about in chapter 2. The groundwater table has dropped 4 or 5 times. What's going to happen?
Hungry water,
but it's going down. It's going down. It's going to cut straight down. And so you kind of have this abandoned tube up top, a fossilized tube up top with a vertical shaft being cut through
a narrow channel. And if we look at image number 4 in your stack, I love this one. It's Fat Man's Misery because your shoulders have so much room. Your head has so much room. Your hips and your lower body, not so much, because that's where you're going through the canyon passageway. So like you said, it's a combination between a tube and a canyon passage because one happens first and then the second part happens. And I just think it's a cool story.
It's a very cool story. Very cool story. I love that one. And it's a combination, like you said, of the two. So let's just summarize here really quickly. We talked about canyon passages. We talked about tube passages. We talked about large canyon composite passages, the one that's a whole bunch of stuff. And then we talked about vertical shafts and keyhole passages, which is our favorite. Let's move into some of the decorations now, the cave decorations, which are beautiful. And we'll go again from big to small here briefly.
And again, we're not going to cover every bit of this, Jesse. We want to highlight some of the things that you're likely to see, and so that hopefully you can make sense of it, recognize it, one, and maybe know a little bit about how these decorations formed. Then these are called speleothems. That's the geologic term for what we're going to talk about. I call them cave decorations. They have nothing to do with the construction of the cave. You build a house, you got it all framed in and then you got to decorate it, right? And that's what speleothems are. So we're talking about stalactites and stalagmites and other features that we're going to get into here, but they have nothing to do with the cave formation. They happened after the cave was built.
After. That's a beautiful, beautiful analogy, Chris. You build your house and then you decorate it. That's what we're talking about. So let's start with the very common ones that everybody's heard of before, stalactites and stalagmites, right? That's kind of where we have to start in a way, right?
I think so. I think, tell me what you think about this, because I don't know if you know what I'm going to say, but the way that I keep them straight, because stalactites and stalagmites are very similar terms. Stalactites has a C in it, a C for ceiling. So they grow from the ceiling down to the floor, okay? Stalagmites, they have a G, stalag. They grow from the ground up.
That's a good one, Chris. That's a very, very good one. I do like that. And I have a confession to make. This is one I don't remember very well. This goes into the category of pumice for me, of like things as a geologist. I'm embarrassed to say rock. I don't really remember very much. I often get this one kind of confused. So let's talk about how they form, first of all. Basically, it's really very, very simple, actually, how these form. You basically have groundwater that's saturated in CO2. It's coming from up somewhere above in the ceiling. So stalactite, C. It's saturated in calcium carbonate. It's dissolved some limestone. It's picked it up. Now it hits the air in the cave, it hits the ceiling and hits the air in the cave. It starts to evaporate, which means that you've increased the concentration of calcium carbonate such that it's supersaturated, such that precipitates calcium carbonate out, and you start to deposit calcium carbonate there. Now, if you have a flow of water that's in one location for a long time, and you do this deposition, you're going to form a stalactite coming down from the ceiling.
That's right. I want to take a crack at this because I think of it in a little bit of a simpler way. Of course, I'm a simpler human being.
Hey, Chris, who goes and gets his mail with his tractor.
That's true. You have no idea what I did today. That's a different story. Okay. But I think of this calcium carbonate saturated water flowing through this rock, and all of a sudden it encounters a cave opening, a room. It's going to degas. It's going to lose carbon dioxide, which is going to cause the calcite then to be precipitated. And I think of this kind of like this degassing is very similar to opening a can of soda. You know, you open it up and it goes like that. It degasses. Well, that is going to cause the precipitation of these really close to being saturated minerals that are in the water. So that's how you get stalactites from the ceiling and stalagmites from the ground. Usually the stalagmites are just below the stalactites. In other words, they're together, right? The stalactites are dripping onto the floor from which the stalagmites grow up. And when they connect then, as they often do, then you have what's called a column.
And it's just a drip dropping down on the ground. It gets deposited. Eventually, those get built up into a column, a really beautiful column on the left side.
They're beautiful.
You have some of these things. They're just totally cool. And people take these things, and scientists who get research permits can sometimes take some, and if you cut a cross section through that, you can kind of date the growth. You can date the carbonate growth rings there, and so it's basically like a tree ring. You can get a growth history and a climate record, a really good climate record out of these speleothems. So they're really beautiful scientific pieces of art, really, in many ways. So I love these things. They're just very, very cool. Super cool. So, Chris, another one that you've seen a ton of is cave popcorn.
Yes,
I have. How do you talk about cave popcorn? And it's image number 6 in our stack. It's so cool. It's so weird. Yeah.
Okay, so it resembles popcorn. It's kind of this knobby, nodule looking like calcite, sometimes other minerals, but in my experience, it's almost always calcite crystals or calcite growth, I should say. So, we talked about stalactites and stalagmites as water dripping from the ceiling. But what about water that drips out of a wall that is just permeating laterally through the rock and it encounters a room, right? Or it encounters a crack that it has room. So the same thing happens. You open up the can of pop, you degas carbon dioxide, and minerals start to grow. Calcite starts to grow. But because it's not coming out of a ceiling as opposed to a cave wall or on top of another decoration in the cave, you get a different look to it. And this can often form cave popcorn. Super common. I love it. You have a really good chance, depending on the tour, to see cave popcorn.
Yeah, such a cool thing. Very, very cool. You can see it in a bunch of different caves as well, including some of the ones that you teach students in every year at the Black Hills, right?
Yeah, absolutely.
The last image in our stack here, image number 7, is flowstone. And flowstone is... it's really descriptive. It's like curtains or drapes. It's like a frozen waterfall. Think of ice waterfall. I did, Chris, a bunch of ice climbing while I was a PhD student in Canada, climbing up frozen waterfalls. They look exactly like this. This is the rock version of this. It's water flowing down cave walls, precipitating out calcium carbonate and getting built up and built up and built up. And they're just stunningly beautiful. And this image number 7 is called Frozen Niagara. It fits. That name fits beautifully, right? I mean, frozen waterfall. It's a calcite waterfall. So, so cool. Maybe my favorite decoration in a cave.
You think so?
I think so. What about you?
I'm a traditional guy. I'm going to just go with stalactites and stalagmites. Stalactites are probably my favorite. And I don't know, there's so many different applications you get these. But Jesse, this is important to note too. Where do you draw the line in terms of speleothems and cave decorations? I mean, every cave has its own intricacies. I remember, I don't know if I took you to this or not, but in Jewel Cave, they have what's called cave bacon. And it's this calcite
I do remember
feature.
this.
You in Wind Cave, you get this boxwork that is just like, to me, I think boxwork is my favorite speleothem, or it's not really a speleothem, my cave feature, because it has such a cool story to it. It's kind of like these keyhole passageways in Mammoth. It's got a really unique story. This one's a little bit more complicated than the keyhole, but I love it. And so where do you draw the line? You're going to see a lot of different cave decorations inside Mammoth Cave for sure.
Yeah, you're going to see a ton of them. Ones we haven't talked about, rimstone dams, all sorts of different stuff, including different minerals. Yeah, frostwork. You're going to see gypsum. You're going to see beautiful like gypsum flowers, different types of gypsum that forms, and a lot of it has to do with evaporating water. You get some really weird minerals that you don't really find in many other places, including epsomite and mirabilite, like these weird things, and they can vary across the cave. In different rooms have different humidity conditions because the air flowing through the cave changes, and it can be seasonal in some sections and not seasonal in others. And so it's actually this really crazy combination between water supply and air supply in the cave system that can create this really delicate balance of where you form and don't form other minerals. So it's a very cool, complicated situation.
One thing that we really need to emphasize too is to resist the temptation to touch the cave walls, because the oils on our skin can impede and affect what's going on in the cave walls, including the growth of speleothems, which is the focus of this episode.
Definitely.
So
and Chris, you'll actually see this.
definitely don't want to do that.
Definitely don't do that. And you'll actually see this in some places where like smoke from the torches that people used to use in the cave has discolored some of the gypsum and stuff like that. So, definitely like do no harm kind of a situation in the cave, and don't touch anything. So Mammoth Cave is exceptional in many ways, including mainly just being the biggest one, but it's such a cool place. Go see it if you haven't. If you haven't had the pleasure of going there, go see it, check it out. We hope this has served as a really good intro across all the different scales of cool geology that you get to see in a place like Mammoth Cave. Yeah, I think that's, what do you think? Probably a wrap of the Mammoth Cave sort of audiobook here?
Unfortunately, yeah. I don't really want to leave it. I think it has a really cool geologic story.
Totally cool geologic story.
It's not simple.
And Chris, I think it highlights, for me, it kind of highlights in geology, as geologists, we have this tendency. We've talked about this with a couple different people on our guests on our podcast, including like Steph Morzak was talking about this. We have a tendency as geologists to study and focus on the biggest or the largest or the best or the most unique. We tend to focus on the crazy, cool, unique stuff. The biggest skarn deposit in history or the biggest cave, and we focus on that. But this, for me, provides a reason or a validation for why to do that, because understanding Mammoth Cave, we've talked about so much important stuff that applies to most caves or many, many caves by focusing on the biggest one, right? The biggest one is the biggest because it's just all the ingredients in the recipe just supersized or supercharged. So you get to learn about caves even though you're only looking at the biggest one.
Let me ask you this. I thought we were wrapping this up, and we're going to here in a second, but
but this is the philosophical one here. And then we're going to end with what Chris did on his tractor today. So,
so one of my favorite things to do, though, is to discuss the formation of a cave outside of the cave. You're right there. You're primed. You're ready to go. Let's get into this. Let's get into the chemistry. Let's get into the geoscience. And sometimes let's get into the tectonics of this beast, right? And then let's go. I love that. As opposed, I don't know. I don't want to do it any other way. I don't want to, let's go see the cave and then let's talk about it afterwards.
No, and Chris, you're right. You don't want to do it while you're doing it. There's a lot of geology stuff where it's like, let's find this amazing overlook. Let's go up to the Absarokas and hang our legs over the edge and look down into the Yellowstone Caldera and then talk about Yellowstone. You don't want to do that with caves. You want to listen to this audiobook before you go to Mammoth, because you want to walk around, eyes wide open, mind shut off, really taking it all in and thinking about what you've learned previously and applying it to what you're seeing. You don't want to be learning on the fly necessarily, or trying to visualize the stuff on the fly.
Or you want to join Jesse and I, and we'll plop you down in a nice picnic area around Mammoth Cave, and we'll talk about the formation of it, and then we'll go on it. We'll go.
We can
into the
bomb
cave
down the bus. I'll take the bus wheel. Chris will take the microphone and just give you the old.
It's a dangerous thing. Don't give me the mic.
Yeah. Exactly right. Yeah, that'd be totally fun. Okay, we should do it. We'll put it on the books. All right. Well, if you're on the podcast, that's a wrap for the third part here of our Mammoth series. And you can go to our app, the Camp Geo app. It's the first link in your show notes. Click on that link. download the app, and there you can get access to this audiobook, the Mammoth Cave one, with all of the images, which we think are really important in some ways for this type of topic. You can also have access to tons of free content, basically our intro level geology class, Introduction to Geoscience, and the Camp Geo content there. Send us an email, planetgeocast@gmail.com. You can also support us by going to the support us link at planetgeocast.com and follow us on all the social medias at Planet Geocast.
Cheers.
Peace.